Alright, so lesson 5, we're going to look at parallel and perpendicular lines. Your warm-ups for each day is just going to be to put these individual lines into y equals mx plus b, which is function form for the line. Alrighty. Example number 1 is to determine whether the graphs of each pair of equations are parallel, coinciding, or neither. The first thing we have to do for each one of these is put our lines into y equals mxb plus form. So, I'm going to start with my first equation here, 3x plus 2y minus 6, and I'm going to change it to 2y equals a negative 3x minus 6 first. And then I'm going to divide both sides by 20, or by 2, and y equals a negative 3 halves x minus 3. I've got to do that with the other equation as well. So my first step is to move the x. So 4y equals a negative 6x plus 20. Divide both sides by 4 so that y equals a negative 6/4 x plus 5. Now 6/4 x will reduce to something. Just so happens that 6/4 x reduces to a negative 3 halves of x. Now, here's how you know if they're parallel. If they have the exact same slope. If they have the exact same slope and different y-intercepts, parallel. Parallel is our answer. Okay? Go on to the next one. Doing the exact same thing. So I'm going to do this instead of using the equal sign. Negative 28y equals a net 16x plus 56. Now I've got to divide by negative 28. Divide by negative 28 on each side, and that's going to change to y equals 16 divided by 28 is going to reduce to a negative, positive because it's a negative divided by a negative, 4/7 x plus 2. Working on the next one. Move my 4x over first, so negative 7y equals negative 4x plus 14. I don't know why I had it plus 2 over here. It should be minus 2 because I get divided by a negative. So, minus 2 right there. Plus 14, change to, divide by negative 7, and I get y equals 4/7 x minus 2. Everything about these lines is the same. If everything about the two lines is the same, we call it coinciding. Okay? Let's go to example number 2 real quick. Let's put this page up. Example number 2 says an inkjet printer prints a 240-page document in 32 minutes. It takes the printer 20 minutes to print the black and white pages, and it takes it 12 minutes to print the color pages. Is it possible for the same printer to print a 300-page document in 40 minutes if 25 minutes are spent printing black and white pages and 15 minutes are spent printing color pages? Okay? Now we've got to figure out how we're going to set this up so that we can use it. Alright? Let's do this. Let's say that X is black and white. And let's say Y is color. Okay? So remember we had pigs and farms the other day? Our pigs on our farm and chicken on our farm? Kind of the same concept, black and white versus color. So first one says there's 20 minutes for black and white and 12 for color. So 20x plus 12y. How many total pages? Well, on this particular one there was 240 total pages. So that's what we're going to set it equal to. Now, do our second one, which says 25 minutes for black and white and 15 minutes for color. Has to equal 300. Easiest thing to do is to start by trying to put these both in y equals mxb plus form. So I'll change this to 12y minus 20x plus 240. Over here I'll change this to 15y minus 25x plus 300. Now I need to divide by my y. 20 divided by y is going to reduce to a negative 5/3. 20 divided by 12. I think I said 20 divided by y. 20 divided by 12 will reduce to a negative 5/3. So y equals a negative 5/3 x. 12 goes into 2400 20 times. Or 2400 goes into 24, or 240 20 times. I've got hiccups so stinking bad. Alright. This side divide by 15. Well, 25 over 15 reduces to a negative 5 over 3. Same slope of x. 15 goes into 30 20 times. If they are the same line, then yes, it's possible. Because they are coinciding, it is possible to print 300 pages, a 300-page document in 40 minutes if 25 minutes are spent black and white and 15 minutes are spent printing. Alrighty. Good. Good deal. Let's go on to example number 3. Alright, example number 3. Oop, mistyped a little bit. That's alright. Example number 3 right up here. Write the standard form of the equation of the line that passes through the point negative 2,5 and is parallel to the graph 3x plus 2y minus 12. Okay? So, here's what we got to do. We got to jump into finding slope real quick and then use our formula y minus y1 equals m open parentheses x minus x1. Okay? Well, if I take this original problem, and remember this is standard form, so here's a and here's b. If I use the formula negative a over b, then I'm going to equal m. Okay? So if I say negative a, that would be m equals negative 3 over 2 as my slope. Now the point that I have is negative 2,5. So then I say y minus a negative 2. Oh, I'm sorry, that's my x value. Y minus a positive 5 equals a negative 3/2 of x minus a negative 2. Okay, minus a negative 2 is going to be important because that becomes a positive, right? So when I rewrite this, this becomes positive in both places. This stays negative. So y equals negative 3 halves of x. Now, a negative times a positive becomes a negative. 2 divided by 2 is 1. 1 times 3 is 3. Now I'd have to add 5 to both sides, so I have minus 5 or minus 3 plus 5, which is going to wind up giving me a final total of 2. Okay? If you want to see what I'm doing, step by step, it goes y minus 5 equals negative 3 halves x plus 2, multiply, negative 3 halves x minus 3, y minus 5, add 5, y equals negative 3 halves of x plus 2. That point right there. Alright. For our next one, we are going to... Oh, excuse me, I still got the hiccups. For our next one, example number 4, we are going to write the standard form of an equation of a line that passes through the point 4, negative 4, and is perpendicular to the graph of 2x minus 2y plus 10 equals 0. So we're going to find the slope real quick. Remember, we said slope can be found by saying negative a over b equals m. So then that would equal negative 4 over negative 2, which becomes 4 over 2, which becomes just 2. Alright, so if I want to find perpendicular, I have to find the negative reciprocal. Okay? Reciprocal means take a fraction and flip it over. Negative reciprocal means flip it over and make it negative. So if I go back to this point right here and I flip it, I'd be looking at 2/4. Now I'm going to put a negative m right here so that I know I'm looking for the negative reciprocal of this m, which would equal put my negative in there, a negative 1/2. The slope that I'm looking for, the negative reciprocal, is negative 1/2. Now I'm going to use my point 4 minus 4, or 4 and negative 4. So, come over here, y minus negative 4 is equal to negative 1/2 x minus 4 as well. So this becomes y plus 4 equals negative 1/2 x plus 2. Subtract 4 from both sides. Y equals neg 1/2 of x minus 2. Final answer. Alright, let's slide this up. Oh, too far. Example number 5. Example number 5. Determine the equation of the perpendicular bisector of a line segment with endpoints negative 1, 2, and 5, 4. Now, in order to find the perpendicular bisector of this, I'm going to have to do several things. First thing that I have to do is I have to find the midpoint between these two. Remember, midpoint formula was x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay. So here are my 2 points, and I need to do that. So I'm going to start with Oh, I've got bad hiccups. I'm going to start with a negative 1 plus 5 divided by 2. And 2 plus 4 divided by 2. And I'm going to wind up with the point 2, 3. So this is the point that my line has to cross through. Okay? Now remember, we have to also find slope of this original equation and then find its perpendicular bisector. So, slope is found in this case as y1 minus y2 over x1 minus x2. So, y1, 2 minus 4 over a negative 1 minus 5 changes to a negative 2 over negative 6, which reduces to a positive 1/3. Now I need the negative reciprocal of this. Flip it and make it negative, so I need negative negative 3. Now I've got to go back and use my point y minus y1 equals m open parentheses x minus x1. Here's the point that I'll be using, so y minus 3 equals negative 3 x minus 2. Carry that through. Y minus 3 equals negative 3x plus 6. Add 3 to both sides. So y equals a negative 3x plus 9. Final answer. Alright, well we just did an example number 5. You and a partner are going to make up 2 points and do the exact same thing. Alright guys, this notes need to be done Wednesday before you come to class. Have a good day.